Hello everyone, let's try to solve the next problem. As you can see, we have one-dimensional movement, but in this case we have not just one object, we have two objects, and the slope of those two objects, of those two functions that show us the movement of those two objects are linear functions, which means the slope is constant, and we know that slope is a velocity. Now, when we look at object A, that the initial position in time of 0 seconds is 5 meters. Okay, we know this coordinate. And the second object start to move from initial position of minus 6 meters at the same time of t0 seconds. Also, we know that when the time is 5 seconds, the position of A, object A, is 3.5 meters, and the position of object B is 3 meters at time of 5 seconds. Okay, what do we need to find? At part A, we need to find the velocity of those two objects, VA and VB. Okay, we know that the slope is, which is actually velocity, as I said before, is constant. Then we can use this formula that is delta x divided by delta t. We need two coordinates to calculate the slope or velocity. Now we see that at time 5, okay, the initial, not the initial, the final position is 3.5, as you can see here, and minus initial position 5 at time of 0 seconds. Okay, we can calculate and find that velocity of the first, or just let's call it A, the velocity is minus 0.3 meters per second, which means that this object actually moves towards the origin, or in the negative direction with respect to the direction of x-axis. Now, what about B? Okay, we'll use the same formula. At time of 5 seconds, the position of object B is 3 meters, and initial position when time is 0 seconds is minus 6. Okay, as you can see, this is the final position, this is the initial position. Okay, when we calculate the velocity of second or object B is 1.8 meters per second. And that's it. That's what we needed to find at part A. Okay, let's see part B. Part B, we need to find or give an expression for the position for those two objects xa and xb. Because we are talking about linear functions, then we're going to use this formula. As I said it in previous videos, t0, x0, you can use whatever you like. I mean, you can use also this coordinate or this coordinate, and you'll get the same result. I'm going to use this initial coordinate for object A to determine t0 and x0. Also, for the object B, I'm going to use this coordinate. So let's see what will happen. Let's talk about A. At time of 0 second, the initial position would be 5 meters. Velocity, of course, we found in previous part, which is minus 0.3. And finally, we get this expression, okay, for position at any time, t, for object A. The same we're going to do to find expression for position of object B. We will use coordinate of 0 seconds, and the position, as we can see on the graph, is minus 6. We calculated before the velocity, 1.8 meter per second, and finally we get this expression that can show us, that can help us to find the position of object B at any given time of t. Okay, next part, C. When and where do the objects pass each other? When and where, okay? Actually, we're looking at this point, okay? Because if when the time goes by, okay, object A moves to the towards the origin. Also, actually, B also moves to the origin, but at some point, okay, they will be they will pass each other. It will be something like here. I don't know yet what is the time, which is when, and of course I need to find later also where, the position when they pass each other. Okay, if as you can see, to find the time and the position when they pass each other, we actually need uh, to say the following. Where is it? I'm sorry. Okay, we need to say that position of object A would be the same position as of the object B. Now we know that expression for position of object A is given by this expression, okay, and B is by this expression. Okay, now we can substitute, but instead of xa we can write this or substitute with these terms, and also when we talk about object B. And there are some few steps, I would say simple steps to isolate finally t, okay, and then we can divide it by 2.1, and we'll get that when is actually 5.245 seconds, which means at this time they will be passing each other. Now where you can use expression for position of object A or B, it doesn't matter because they have the same actually position at this time. I used a function that describes the position of object A. You can use also object B. Okay, then I can substitute the t by 5.24, and finally we get that the position when they pass in each other is 3.43. Okay, so that's the passing point between those two objects. Now the following part D, the question is when the distance between the two bodies is 1 meter. Now let's see first possibility is when A, okay, I'm talking about this possibility when A is above B, okay, which means as I see here, the position, if the position of A is I don't not higher but above B, and if I want to subtract the position of A, B from A, then if I want this subtraction would be positive, like 1 meters, okay, then I should write something like this. The position of A minus the position of B, in this case, should be 1. Because if I do something opposite, like xb minus xa, which means the subtraction would be less than 0, then I should write something like this minus. But I don't want to do this, okay? I just want to find when A is above B, and I want the subtraction would be positive number 1, then I should write as xa minus xb equals 1. Now what we're going to do next step is just we will substitute this xa with linear function of xa, and we'll substitute xb with linear function of xb. Then you see a few simple mathematical steps, okay, and we find that the first time when the distance between those two objects is 1 meter happens at time of 4.76 seconds, or 4.76. Okay, second case, okay, when they pass each other. At this point, now we see that xb above xa. And this is the second time when the distance between those two objects is 1 meter. And again, if I want that difference between B and A would be 1 meter, I should write xb minus xa equals 1. And again, we're going to substitute xb with linear function of position of object B, and also we will substitute the linear function of object A with this expression. Again, some simple steps, mathematical steps, and the second time, as we can see, is 5.71 seconds. Okay, so we have 2 times, okay, when the distance between those two objects is 1 meter. And I think that, yep, that's all parts. Okay, I'll see you in the next problems.